Hello everyone, uh, this is Stavros Shaelis and today I'm going to present the detection of insider threats using artificial intelligence and virtualization. This work was conducted under the H20 project called Cybertrust under the agreement 786698. And which is called Cybertrust. And we're going to discuss a few things about these insider threats and our research work about how you can detect these insider threats. The outline of the presentation is as follows. So we're going to see a bit of introduction about insider threats, what insider threats, etc., the motivations of this work, some background information, proposed solutions, experimental results of our proposed solutions, and some conclusions and perspectives of this research work. Of course, if you have any questions, you can feel free to mail me whatever you want, and I'm happy to reply to you. So, what is an insider threat? So there are many definitions in the internet, but generally, an insider threat, it's someone, it's a person which it's an employee in the business which it feels that it feels intimidated and feels that it shouldn't be there because of the way that they're treating them. So these people, let's say, are vulnerable to external, let's say, cyber criminals because they don't like the company that they work and they could pose a risk in this company. So there is a big problem with insider threats, and we'll see in the next slide as well some statistics and what is happening with insider threats. So these people, because of the way that they feel, because the way that they behave to them, they feel intimidated. So based on all of this, they are more vulnerable to install, for example, a malware, a ransomware, a Trojan, something that it could harm the company. So we have two categories of insider threats. We have the accidental and we have the intentional. Okay, the accidental, as you understand, it's negligent employees. So basically, by mistake, basically, is doing something that it could expose security risk. For example, forgot the password on the desktop on a paper, so someone could see it and have access to it. The other one is the intentional, which this has to do with these granted employees. As I explained before, employees that they don't like how they treated, they don't like how they get paid, they feel that they don't pay well for what they're doing. So these are the most dangerous and they can create a big data loss and problems to a company. So motivations of insider threats. According to these statistics, over the last 2 years, we have a number of insider threats increase. So according to Panda Security, as you can see from this slide, there is an increase of 77%. Also, from CISA InfoSec, we have 34% of business around the globe are affected by insider threats yearly. As you understand, that's big numbers, 34%, one third, let's say, of the companies around the world they've been affected from insider threats from people that they create damage and loss. So it's a big problem, and also the cost, according to tech jury, it in 2020 was estimated 2.79 billion, million dollars. Okay, so some examples of insider threats, as you can see here, we have the Tesla employee which steals and sabotage company data. We have Facebook, a security engineer abuse his access to stalk women. Sandra's bug, malicious insider stole personal data from 1.5 million customers. So that's some examples of insider threats. Um, Other example is Coca-Cola, malicious insider stole hard drive full of personnel data. So as you can see, big companies and which they have high security like Facebook, uh, they suffer from insider threats. So defend tips available from insider threats is monitor the activity, files, emails on core data sources, identify and discover where sensitive files live in the company network. It's very good to know who has access to the data and who should have access. Maintain least privilege model through the infrastructure. You apply security analytics to alert abnormal behaviors and train uh, employee personnel to adopt data security mindset. As you understand, this is some practices. Many companies they have monitor activities, etc., for emails, but this is not enough. We need something more. We need systems that they will run. That's the reason we think that AI it will be something useful for detecting insider threats. So based on all of this uh, research, you can see all of these incidents happen and the need in the industry to mitigate this problem, because they can have the best security measurements, the best systems, security systems, the companies, but the inside threat is someone that is already in the company. It's like you have a Trojan inside your company. So in this respect, uh, insider threats, this is the motivation. Insider threats, it's a big problem. Is an organization cannot rely on what they have. They need new system. They need something new in order to, let's say, detect, predict if something will happen before it happens. Because if it happens, then it will be too late, or stop it as it's happening. So the idea of this research it was to investigate and propose a new method that could be successfully detect insider malicious activity. Uh, for this reason, we for this solution and the aims that of the proposed solution to if we are able to detect legitimate and malicious user activity using visualization maps. Basically, we produce based on log files based on activity from a data set, public data set, which is well known from the Carmen Mellon CERN. So we use this dataset, and we wanted to see if there's a way these log files to be uh, visualized into a picture. And based on this picture profiles, this picture, it will reflect each user profile activity per day, per week, per month. So we have various pictures, and then after we have this activity, let's say picturize, to see if we can use some machine learning algorithms using TensorFlow, Google, to see if we are be able to detect the malicious activity after we train, of course, the machine learning. So this method, it has 3 stages. We have the input data pre-processing, we have the image, as I say, um, that we have a dimension, 2 dimension heat map for each user activity, and then we have the image classification using learning. So this data, as I said, it was a synthetic data set available from the CERN of Carnegie Mellon University CERN. It is well established in the literature review. Many people use it for this purpose. So first we download all of this log file, which is pretty big. And inside this, we had many log activity. We have raw input files, and from 15 users, okay, according to what they say about this dataset. And we create profiles that they were built, let's say, on 3 files inside this dataset through the file CSV, email CSV, and HTTP CSV. So as you understand, each file it has the files added on the computer, download, etc., email, the email exchange, and HTTP, the websites that the user visited through a period of time. So also in these 15 users, we have the login records, files, documents used, open, etc. As you can see from this area here. Okay. Then based on that, we use a method using heat maps, let's say, and we produce picture, which I will show in the next slide. So produce of image for each user. I said that we have 15 users. So use these colors. That was something that we thought it is our idea about the image. It could be different. It could be more colors or less colors. That was what we thought, and we wanted to test it. And this is the idea of this work. So we have here blue, red, pink, green, yellow, and orange. As you can see, each one it's going through the specific thing. For example, blue is social media professional interactions such as job search, etc. Red is sharing site, pink email threads, green is for file threads, yellow is the attachment site, and orange is the email attachment. So if it's between 100 and 200 email attachment, and this color it changed from orange to brown if it's more than 200 kilobytes email attachment, which means that we have more files sent, which this could be an indicator of something is exported through the company. So the stage 2, it was to create this image. So we have the picture you can see with the features on top and the months and the date of the months 1 to 3 and 231 based on the month because there are different months in the datasets, and based on the color code I explained before and the log activity, we start putting some colors on this map. And as you can see, we have, for example, in the first picture here, we have the user's weekly normal activity, and for the same user, we have this is the weekly, so 1 week, and we have also the monthly normal activity. So this is an example of normal activity of a normal user based on also on the dataset. So we produce these pictures, and there are pretty many pictures that we created. And the next step, it was produce. So we did this for each user, and this is some example of malicious activity, as you can see, and here a monthly malicious activity. As you can see, even the picture, they look different. The malicious activity seems with specific colors and also more dense of the activity, for example, of HTTP links, etc. So we create these unique pictures for each user, and then we came into this stage to see, okay, let's see what TensorFlow, what machine learning can do. So we use here CNN, a 6-layer CNN. The dataset had 860 images, including an equal number of normal malicious activity samples. So we use for the training an 80% of the image. So we have equal this 80% malicious and good and legit users activity. So we train this CNN network, and then we use the next 20% for the validation to see if it can catch the users that is not already provided to these training sets, because they were, according to the dataset, there were many good users, and there were 4 or 5, I don't remember now, malicious users. So we trained it on 2 users, and we left the others to see what will happen. These some results of the accuracy. As you can see, it started low, and as it was providing more images, we reach in very short time to, as you can see, close to 100% accuracy. And the validation accuracy was reaching pretty high. We have some peaks here to 100. So I would say it was 19% through the time, through the more image we was providing, there was better the accuracy as well. And as you can see here, we have a decline cause about the false positive, etc., as it was uh, uh, more image was provided with training. So comparison of our work between other studies. We have this, we have Britska and all, which was each method basically they provide some information, but they're not pretty accurate what they're saying. For example, Beer and all, Leg, Wang and Ren, they don't provide any measurements. Even if we have something from Briska, and here, as you can see, they provide the testing accuracy 95%. We have here indications from Young and all. We have 87.4 probably of accuracy. So I'm explaining here the comparison. This I propose an approach combining structure, anomaly detection, etc. So all of them, they have okay, different accuracies, but in our case, our proposed method has an accuracy of 100% based on the test we did, and the validation accuracy was reaching 90.6%. So our method of producing these images along with CNN, because we already know that CNN is very good with image classification. So all the idea was to produce the best image idea in order to have this classification. So as you can see from this paper, from this work, we reach pretty good accuracy of detecting malicious inside. So, conclusions from this work. As we said in the beginning, the aim of this research was to investigate the feasibility of using machine learning to detect malicious activity. And all the idea, all the method was how can represent these log files to an image that will make sense to the machine to find these differences. And it seems that we have achieved that with our methods with a pretty good accuracy. So future extensions, I will say, to use different algorithms, different machine learning algorithms to see maybe better better accuracy. I wouldn't say because we have pretty good accuracy, but I don't know if we use different data sets. So the idea is to use different data sets from the CERN as well to see what happens, or put more features or tune better the picture. So ideally to use a bigger data sets and use more info, let's say, more features. And one of them, which is very interesting for us, it's the psychological profile, which is available in these datasets, which we didn't use them. This is basically for prediction. And as you can see in this method, we didn't deal with prediction because we use the files and HTTP request. So it could act as prediction because if you see a lot of activity like this, it could be a prediction of user, but it also it can act as post, let's say, detection. But the idea of inside threats is to have a before it happens to find this activity, and I believe the psychological data will make this more valuable. So uh, ideally it's this to improve this method to use more samples, more pictures and more data, and use other machine learnings and compare our methods with more other people. And that was the presentation. Thank you for your attention. Uh, if you have any question, please drop me an email at sshailis@ieee.org, and I will happy to discuss with you or collaborate with you in whatever you will need. Thank you again. Bye.